Hello everyone, and welcome to today's webinar on CAM and education. My name is Don LaCour, Senior Application Engineer with MecSoft Corporation. I want to take a moment to introduce our other MecSoft panelists. We have with us today Anita Anand, MecSoft's VP of Sales. Anita will be reviewing our educational products and resources. We also have Joe Anand, our MecSoft Product Manager, and Uday Hanalagre, our Technical Support Manager. Both will be on hand to answer any technical questions you might have during the program. Uday will also be managing the slides and the mechanics of the webinar, and I appreciate that, Uday. Now, before we begin, I just wanted to say that CAM and education is very important to us here at MecSoft Corporation, and it's very exciting as well. We partner with many schools and universities around the world, and in most cases, our software introduces CAM technology to young adults for the very first time. They then have the opportunity to carry that knowledge, CNC machining, directly into the workplace. Uday, could you go to the next slide? We have presentations lined up today from Montana State University and Wrangell Public Schools of Wrangell, Alaska. We also have a demonstration of RhinoCAM, our flagship educational product, and we will also be reviewing additional education information and resources. Next slide. Now, just a few housekeeping tips before we get started. You can use the chat window in your GoToWebinar dialog to submit questions. The last 10 minutes of the program will be reserved just for that purpose, so please feel free to ask us anything you like. Also, this webinar is being recorded and will be made available on YouTube in a couple of days. Okay, we have a really formative hour lined up, so let's get right to it. Next slide, Uday. As I mentioned previously, we have two very special guests on hand with us today. Our first guest is Mr. Bill Clinton. Bill is a professor in the School of Architecture at Montana State University. Bill has been teaching graduate level design, construction, and materials classes since 2003, and is the fabrication shop manager as well as the equipment and facilities manager for the School of Architecture. Bill has created a digital technology room which houses laser cutters, a rapid prototyping machine, a 3D digitizer, and two 3-axis CNC machines. About 350 students in the MSU School of Architecture learn CNC laser cutting, 2- and 3-axis milling, additive manufacturing, as well as rapid prototyping. Bill will be discussing how RhinoCAM has been introduced into the curriculum there at MSU. We also have Mr. Drew Larrabee with us today. Drew is the Industrial Technologies Instructor at Wrangell Public Schools in Wrangell, Alaska. Drew started his teaching career as a geologist, teaching math and sciences, but has since spent the last 4 years teaching digital fabrication, where he and his class produce some wonderful projects. Drew will be discussing the introduction of RhinoCAM to his public school students. Let's start with you, Bill. Next slide today. Let's start with you, Bill. Welcome to the webinar. Tell us about your use of RhinoCAM there at MSU.
We have used RhinoCAM for about, I'm going to say 8 years. We introduced this program into our curriculum in second year. We have a 5-year program here. Start off very, very simply with having them mill foam, and they learn 3D tool paths, they learn 2.5D tool paths, and many of those students who learn RhinoCAM in those very simple sessions go on to really love the CNC machine in particular. They realize at some point that they can create these 3D shapes that are almost impossible to do any other way. And then I introduce it again in my classes. I teach 5th year graduate level design build class. Let's just change slides. We'll talk about some of the work. This is a class that I taught several years ago, and I asked the students in this class to work collaboratively and design a machine that would indicate the passage of time. And we're obviously used the CNC extensively with this project to make the gears, to make the case, to make the mold, to cast the lead weight even. We used the RhinoCAM and our CNC machines to do all that. What you'll see in this picture are students assembling the last mock-up that we did, and in the upper right-hand corner you'll see the gears being cut. To get as flat a material as we could, we made our own plywood in vacuum bags. So we used 16th-inch veneers, cross-laminated the veneer, and made very, very flat wheels for our clock mechanism. It performs well. Actually, it's still running. It has to be wound once a day, which is the problem. I just told them they had to make a machine that would indicate the passage of 24 hours, and this is what they came up with.
That's nice.
We can go to the next slide, I think. I'm a musician, and I incorporate music into the architecture program. There'll be a couple slides later on that we'll talk about that. But for me personally, my research has been into building instruments, and I'm a guitar player. So I decided that to build an electric guitar, which is my main instrument is electric guitar. And I wanted to build as much of it as I could. And building the bridge was important to me because I have certain parameters that I use when I play, and I like the feel of this aluminum bridge. So it was a challenge, and the students, it was fun to see them watch me do what I was doing, and then suddenly a whole bunch of students wanted to make electric guitars. It's kind of funny. But in this case, we're seeing an image of the bridge, and it was, the only thing I had to do with this bridge is polish it, actually, after it was milled, and that may have taken probably almost as long as it took to machine the bridge. We do a lot of wood machining. You can see the body and the pickguard and the neck of this guitar was made from wood. We also mill metal to a certain extent. Students, one of the things that I have to teach them is materiality and connections, and they're pretty unsure about how fast a router needs to go, especially when they get to metal. So they're pretty tender about approaching the metal part, and I know it's helped that when I'm in the shop doing my own work, they see it and they go, oh, well, I can do that too. So it's been a fun thing. I've made several guitars, and I'm on to my next iteration this semester. So
that's nice.
Well, thank you. We can change slides. This is in the upper left-hand corner. You'll see an instrument that I built. It's a glass-keyed xylophone, and the machine was used for lots of stuff on that. But mostly, you'll see in the right-hand corner there, the mold that casts the silicone rubber that holds the glass keys for the xylophone. And again, I'm trying to teach students about connections and materiality, and frankly, it's hard to teach a student how to be a furniture maker in 15 weeks. It's hard to teach a student how to understand the whole depth of craft in 15 to 16 weeks. And so I try to, what I really want to get out of this, the courses I teach is connections and materiality. Lots of students come into this class having never used a power tool ever, of any kind. So it's a pretty steep learning curve for them. The drums you see in the lower corner, or the lower part of the screen there, a student milled all those parts on CNC. He had to mill both sides of the sheet, which took some explaining how that worked, and that was, and also the connection in the middle was machined on the CNC. And that's another thing. We talked about jigs, how you can use the CNC and RhinoCAM to make jigs to make a piece. So there's that whole other level of learning when it comes to to making parts, making a tool to make the parts sometimes comes into play. And I think we can go to the next slide. This was a really interesting project. We were asked to be part of a collaborative effort with the School of Architecture and some geology students and geology professors to make a site model of the Bay of Naples, sorry, for the Atlantis exhibit at the Museum of the Rockies, which is currently running now. This exhibit there's only 3 museums in the country that is coming to. MSU is the largest and the longest running exhibit, and it's also the most expensive exhibit the museum has ever mounted. So we knew we had to do the right thing, and our students came through with flying colors. As a matter of fact, we're up for a university award for this project. No other museum is doing this kind of stuff, but we realized that we could collaborate with geology and create this a site model of the Bay of Naples, and concurrently with a video that's running on a wall, the projection from overhead projection onto that surface is chronicling the eruption of Mount Vesuvius that affected the Atlantis villas, which would be sort of, I guess you can see it there, that orange section. That's kind of where the Atlantis villas were. This was a really interesting collaboration. We had students who were geology students who knew everything about geology but knew nothing about CNC, and we had vice versa. Our students could run the CNC machine and understand how to do that, but they didn't know anything about geology. So we collaborated, and with this site model, converted pretty extensive high-definition files from the geography of that region into point clouds, and then draped the point clouds and cut that model out of high-density polyurethane foam. And I certainly checked that file about 20 times to make sure, because that piece of foam cost about $900. So we wanted to make sure that we wouldn't have any trouble, and we didn't. And it has been very successful. This model will probably go back to Italy. These objects from the Atlantis villas have never been out of Italy and may never be again. And it sounds like all the stuff that we created will be going back to Italy, which is kind of cool, actually. We're excited, and there's some hope that not only will the models go back, but we'll go back with the models. So I'm really excited about that possibility.
Hey, Bill, I'm wondering something while we're looking at this picture. Where did you get the topology, 3D topology for the RhinoCAM topology to cut this part?
You know, that's a really good question, and I can't exactly answer that question because it comes from some really high-definition files that that geology had given us. And they were such high definition and so dense that we actually had a little bit of trouble with it at first, and not with the milling part, but with translating that point cloud data into a drapable surface.
Yeah.
So we worked with the students, and I can't tell the exact program they were using, but it's something kind of proprietary to geology that I don't think is available to anybody.
Nice.
Yeah, it was a good project. We, like I say, we formed some bonds, and these collaborative projects always turn out well for us when you get a group of students who are interested and engaged, and that's a wonderful experience when it all works.
Okay. Well, I appreciate that, Bill. That was great. If you could, Bill, please stay with us for the Q&A session at the end. Some of our attendees may have some additional questions. I appreciate that.
You bet.
Uday, could we go to the next slide? Our next special guest is Mr. Drew Larrabee, the Industrial Technologies Instructor at Wrangell Public Schools in Wrangell, Alaska. Hi, Drew. So tell us how your students there at Wrangell Public Schools have embraced RhinoCAM in digital fabrication as well.
Well, Don, that's actually a long and twisted road to get to that point, but let me start a little bit backwards, because this is probably how most teachers are going to come into using your product. Well, maybe not quite as convoluted as mine, but as you stated earlier, I'm actually a geology major.
Mm-hmm.
And I'm sitting here listening to Bill's explanation, and it sounded like a really neat project. But I actually started out as a vertebrate paleontologist building dinosaurs in South Dakota long ago, and then worked as a environmental engineer, and then a bunch of other stuff, and finally ended up in Alaska to teach. And came here as a science and math teacher, as you stated, and did that for several years, and that was in the far north Alaska, very, very cold area, near the Arctic Circle, where it gets dark for the majority of the year. But I transitioned down to another school district, and they said, well, we noticed on your resume that you used to do construction and engineering and stuff. Would you be willing to teach a furniture class, a carpentry class? And I said, well, I suppose I could do that. And that class turned into 2, and then 3, and then half my schedule was done doing vocational classes. Mm-hmm. And I started
How did you like working with the students?
Oh, I love vocational. It's neat because the students come into the classroom and they really genuinely want to be there most of the time. You don't get the arguments like you do in math class. Oh my God, why didn't you do your homework?
Yeah.
So it was really fun, and I've always done construction. That's how I got myself through college, and so I love building things with my hands, and so it was really just a natural fit for me. And I found that putting science and math into the vocational classroom was a natural fit. Teaching math using vocation is much easier than teaching math out of a textbook. So I started incorporating science and math into all my vocational classes and made them a mix of STEM classes. And STEM is a term that we use a lot in education now, which is science, technology, and math. And so I started incorporating that. And I worked for that district for 5 years. Teaching that combination of stuff, and got to meet a lot of people in the state education associations and stuff, and going to different conferences, and met a fellow named Randy Huey out of Sitka, and he offered a RhinoCAM training, and this happened right about the same time I changed jobs, and I moved down to Southeast Alaska and was offered a full-time vocational position, teaching everything from welding to carpentry to furniture building and everything. And as we spoke earlier with Bill before the conference, I also learned furniture building just as a hands-on, just out of necessity, and have really developed it over the years. But I started to see that the students really have this, it's really hard to tear the cell phone out of their hand long enough to run a table saw.
Yeah.
So I decided that really needed to be incorporated into my classroom, the technology and learning to use that, because that's really the direction that our society is going with manufacturing and everything. And I was leaving an entire group of students from our school population out of my classes, because typically you get the shop kids, the kids that don't necessarily do so well in their other classes and everything.
Right.
But there's a group of kids that love running computers and are very intellectual and not necessarily willing to run the table saw. So put them into the classroom running computers. Well, Randy Huey at that time offered the training for CAD 1, and so I went and took that training. I'm thinking, well, this is great. Let's get going. And at that time, I had one PC computer and a 3D printer, a small 6x6x6 3D printer that was given to us for the training. And I brought that home, and I showed the students, and we were learning and having fun with the little 3D printer, and I realized that just wasn't going to be enough, because they were eating that up really fast. And so I sat down that spring, and I wrote a huge grant to the state, enough to buy new computers for the shop, a 2-axis 50-watt CO2 laser, an additional 3D printer, a much larger one, and a 3-axis CNC router. well, didn't know what I was getting myself into with that whole deal. And once it was all on the ground, I looked at it and said, now what do I do? And so my limited experience with Rhino, I started tinkering and playing and designing projects and calling people and making it up as I went along. And I quickly realized that the students were going to outpace me. And so I really sat down and started learning a lot. But as you guys know, schools often have a very, very limited budget. And so I decided we had to get some kind of CAM program to run our 3-axis router. And at the time, we just couldn't get the free programs to run the toolpaths and stuff that we wanted to design, and I was just learning about toolpaths and trying to figure out how to run them. And so we ended up with, and I'm sorry, I'm going to throw out a competitor, we ended up with BobCam, which was a cheap program, inexpensive, not free, and we tried to use that. And so we started out with basic 2D toolpaths and cutting some signs and some stuff like that and just shapes and stuff. And I had a senior who did his senior project that first year and cut a great big bench. And it was it looked like a tree, and it was 3-dimensional, and it had a big round bench that went around it, and it was 8 foot diameter and 8 foot tall, and it turned out pretty well. But in the process of doing that, we learned the limitations of going from Rhino to this BobCam. We had so many problems with snap points and modifying the design once it got in there and laying it out and making toolpaths, and we absolutely positively couldn't do any kind of 3D work. We just couldn't get it to work between Rhino and then over to BobCam, and so we got terribly frustrated with it. I mean, repeatedly just problem after problem, and it was a really difficult thing to keep the kids interested when we were having so many problems.
Yeah.
And so that's when I started looking and trying to figure out what I was going to do. And so I started talking to RhinoCAM and realized that I could afford their entry-level setup, and we got it in and we started using that. And talk about a world of difference. It just worked well with Rhino. I mean, everything moved right over. It was a drip, just plopped it right in, and the kids could produce stuff, and you know, no problems with snaps and planes meeting and stuff like that. And it was so much more pleasant, and the tutorial videos were easy to follow, and the kids, because they were used to working in Rhino, they could start picking it up.
Yeah, I think this would be a good point, Drew, to show the next slide here. That's
yep, and that's what I was
RhinoCAM project.
Go to the next slide. So yeah, if you guys could go to the next slide, that'll be perfect. So we were able to start building, and these are students, so we don't have a big budget for outside projects and stuff. But they really got a lot of interest from the community. And you know, one of the small first projects we did was we had an individual. We've got a big shipbuilding yard here in the community that actually supports a lot of jobs. And one of the big fiberglassers came in one day, and he says, I hear you guys have a 3D printer. And I said, yeah, absolutely. He says, I've got this part in this old 80s vintage fiberglass cutter, and I can't replace this part. They don't make it. And he said to buy a new tool is thousands of dollars. He says, I just can't afford that right now. He says, can you make this part? And I said, well, I don't think the 3D printer will hold up for the part. But I said, we can make the prototype, and then we can send it to an outside service to have it minted in something else, like stainless steel or whatever. And we did. We made the gear. I had one of my students actually design this. It was an offset 45-degree face gear, and it was pretty unique shape, and I had to teach him a lot of stuff. But he printed it. We sent it out, had it minted, and the man put it right into his machine, and it functioned immediately.
Wow, that's great.
That got the community hearing about the things that we could do. So then we started getting requests for things like parking signs, and this sign that you see here on the screen is a sign for, we've got a lot of tourism in our area because it's southeast Alaska, very beautiful. And we have tourists that get lost around our community all the time. And so the city started asking us to make signs, and these are out of the 3-core polyplastic, the HDM plastic. And so when you carve off the surface, the inside color is different than the surface, and we can create these really neat signs with relief to them. And so the students started manufacturing and making these plans, and we discovered just how easy it was to do things like V-carve and stuff like that with RhinoCAM. And we're able to start making projects that the students could do. This last spring, excuse me, we had a prominent pilot in our community crashed his plane, and he and 3 other people died in the crash. And the family approached us, and we ended up making a headstone for his grave with out of very, very beautiful African mahogany, and my students designed and carved the headstone for him.
Wow, that's nice.
Yeah, in a similar fashion. And so there's a lot of things like that in our community that the community comes to us and has us do. So aside from a lot of pro bono projects in the community, if you go to the next slide, I'll show you what our Keystone project is. Our students, before I came here, the previous instructor had built a marine fabrications program, and the kids had been building boats for 20 years. And so our high school students each year build between 1 and 3 aluminum boats, and these are full-size 20-foot jet or ocean boats that they are paying for the materials and building on their own.
And you're using RhinoCAM to build these?
Well, we're getting there. So they used to build it manually, and so then when I got here and I started using the RhinoCAM and everything, we started seeing how we could start manufacturing the parts more precisely, because they were manually cutting them with skill saws on the aluminum. And so we started designing out some of our basic jet boat designs on Rhino, and then transporting them over to RhinoCAM to make our cut sheets and things like that. And in the picture on the right there, you can see our first set, well, excuse me, that's our second set. The first one we cut was a small 9-foot rowing pram for going to the beach from a larger boat. But here you can see all the parts cut for 2 14-foot jet boats. And this was designed out, and you can see on the left there, we cut a 1-to-1 scale model and had the kids put that together, glue it together and everything. And the layouts that you see there represent the half sheets of aluminum that we used on the machine to cut it. And once all those parts were cut, they actually put the boat together. And you can go to the next slide now. And here you can see the students assembling that jet boat. There's one there and one behind the students sitting next to it. And we were able to put that jet boat together with a precision that we weren't able to do in the past. And so designing them out and actually machine cutting them was an amazing step forward. And we're actually working now to make a program, a statewide program or a regional program, where we can start cutting parts for districts that don't necessarily have the technology or the facilities to cut and manufacture their parts from scratch, but have a welding facility where they may be able to assemble it. And so what they would do is come to our school and have a weld training program. We would use our Rhino program and our cutters to cut the parts, bend the parts that needed to be, palletize it, and send it to their district where they can then start to assemble it.
Yeah, I see this next slide here coming up. That's the boat complete. That looks...
Yep, let's go to the next slide there and you can see it.
Now, did you take this out on the water?
Actually, it's been running around since its completion. The student that finished it ended up blowing up one motor already and rebuilt it. But it runs off of a jet ski motor, about 120 horse jet ski motor. The boat itself is light enough that the students, 3 or 4 students, can pick it up. And but we have the Stikine River here, which actually runs up across the Canadian border. And the students that built this and the one next to it use that boat frequently for moose hunting trips and just weekend cruises and stuff. And it runs beautifully. It came out very, very well.
Well, that's great, Drew. I appreciate the discussion in the presentation. Uday, could we go to the next slide there? I wanted to mention here that if any of our if any of you, our attendees, have questions for our guests, just type them into your chat window, and for our Q&A session coming up here in a few minutes. Uday, if you could go to the next slide. What we're going to do now is give you a quick RhinoCAM demonstration. And Uday, if you could go ahead and make me the presenter, I will go ahead and give the demonstration. Can you guys see my screen all right?
Yes.
Great. What I've got here is Rhino 5.0 loaded, and I have a part on the screen here. Now let me close this browser just a second so you can see the whole thing. What we have here is a CO2 racer model. Now you may be familiar with Pitsco. They manufacture and sell modeling kits with the blanks of wood, and you can machine out your own race car, put your CO2 cartridge in, and you can actually race these. So what we have here, we have a racer, and I've got a split plane here, right here in the middle of the part, because as you can see, there's features on the bottom and on the top. So what we're going to do here in the quick demo is we're going to show you how we machine the top, and then I have another file loaded. I'll show you what it looks like after we have already machined the bottom. Now, RhinoCAM is a completely integrated plugin that runs inside of Rhino. So it has you have the RhinoCAM menu here at the top, and there are multiple modules that you can get in RhinoCAM. You can get the milling module, a turning module, nested module if you want to nest parts, and also an art module if you want to do 3D release from images. That furniture makers do that a lot. So we'll go ahead and load the mill module, and over here on the left you see the mill module browser. So everything that you need to do to create toolpaths is right here in this browser. And it's divided up into two sections, the machining browser and the machining objects browser at the bottom. And basically to create toolpaths, you just work from left to right on the program tab to create your toolpaths, and then you have a simulate tab that you use to simulate. Now down here in the machining objects browser, you have a number of tabs here. As you can see, we have a tools tab, and I have two or three tools already created here. But I'll show you how easy it is to create tools. You have a create a tool dialog, and we support all these different tool types, from ball mills to end mills, V-cutters, facing mills, fillet mills, and drills and taps and reams and bores. And also here we have a custom defined mill, where if you have a mill that's not standard that you have had made, you can define that in RhinoCAM simply by using a two-dimensional profile and loading it directly into the dialog. And then also over here you can define your parameters, and you can define your properties of your tool material, tool number, etc. And then you also have feeds and speeds that you can assign to the tool, and you can also display a built-in tool calculator that will suggest different feeds and speeds and cut rates based on your material, your stock material, and your tool material. So let's go ahead and close that. So I've got 3 tools already created. Then we also have other tabs here. Most importantly, I want to mention the K-Bases tab. Anything that you create in Rhino, any tool path, any tool, you only have to do it once. You can save your tool paths to a knowledge base and load that knowledge base whenever you create new parts. And over here on the Tools tab, you see commands here to load a tool library and save your tools to a library, etc. So you only have to do things once. Now, I have a couple of machining operations here. I wanted to go ahead and get rid of those because I'm going to show you how to do those. Now, from the Code Program tab, it's really easy to create toolpaths. We'll just work from left to right. We'll define our machine, and we're going to use 3-axis operations for this. But RhinoCAM supports 3, 4, and 5-axis machine tools, so we'll go ahead and set that to 3-axis. And then for the post, we have our post default to Haas, but RhinoCAM supports over 200 different post processors. for all the popular controller types. Even if your machine has a controller that's not on our list, as long as it accepts standard Gcode, we can help you create a post for it. So we'll set the posted file extension to NC, and you can add more extensions to this very easily. We'll pick OK there. Now, for the setup section, RhinoCAM, when you load RhinoCAM, it comes with one setup by default, and that setup is aligned with the world origin in Rhino. Now, a setup is used to define the coordinate system of your machine tool. So as you can see here, we can display that on and off, and you see our setup here aligned with the world origin. It aligns it X and Y with our part, and the Z depth is the direction that we're going to go to cut. So we've got one set up already. So we'll move over to the stock section, and you have a number of different stock options. I'll go ahead and define a box stock, and I have some default dimensions already entered in here for our stock for this part. But if you have a part and you don't know what the stock size should be, you can just pick this copy model bounding box, and it'll tell you the size of your part, and you can just add some dimensions, length, width, and height to define your stock size. So we'll pick OK there. Also, you're going to want to align your stock to the part. So this allows you, this is your part and this represents your stock. You can move your stock in alignment with the Z-axis. We'll put it at the bottom of the part, and then we'll align it in the X and Y to the center of our part and pick OK. And you can also display the stock, turn it on and off on the screen here. So there's our stock created. Now what we're going to do is assign a material to the stock. So we'll select the material option, and we have it set to wood currently, but there's a number of different materials that you could choose from, and you can easily add materials to this list if your material is not in here. So we have that set to wood. So we've completed the machine setup section, the stock section, where we're following to the right, and we'll go ahead and create a work zero. This will be our machine 0 point. You may not want to zero out on this bottom corner. You may want to zero out somewhere else on the stock. So we'll go ahead and create a work zero, and we'll set it to the stock box. So for the top zero face of the work zero, we'll put it to the highest Z on the stock, and then we'll move it over to the southwest corner of the stock directly above our world origin in Rhino. So let's go ahead and generate a work zero. So now we got a work zero there that we're going to use in all coordinates for our toolpaths we've measured from that point. So now RhinoCAM supports, like I mentioned, 2 through 5-axis machining toolpaths, as well as whole machining operations. Let's just go through these real quick. In 2-axis, you can do roughing, facing, profiling, all the way up to remachining in 2-axis, and you don't even need a 3D part model. You can just do 2-axis machining just from 2-dimensional curves. We also have on our 3-axis dialog a wide range of 3-axis operations, from roughing operations, finishing operations, detail operations such as pencil tracing, and we got radial and spiral machining, curve machining, a lot of different 3-axis machining operations supported in Rhino. And then if your mill has a 4-axis rotary attachment, we have continuous and index 4-axis operations here. And then also if your mill is a multi-axis mill, we also support both indexed and continuous 5-axis tool paths here. So we're going to go ahead and create a 3-axis roughing operation, because we have a lot of material here that we want to get rid of initially before we go into our finishing operation. So we'll go ahead and go to 3-axis and select horizontal roughing. Now everything you need to do to create your toolpath is all defined within one dialog. Makes it real easy. There's a number of tabs up here, and we'll go through each one of them real quick here and show you. For the control geometry, for horizontal roughing, you don't need to select anything here initially, because RhinoCAM will figure out where the stock is and where the part is, and it'll calculate your roughing operation for you. So we can skip that tab. For our tool, we'll go ahead and use our 1/4-inch end mill to rough it out. Feeds and speeds, you can set these here, or you can load them from the tool. For my part here, they're already set to the tool, but you can override those if you want. For the clearance plane, this is where the retract motions and cut transfer motions are going to take place, and we can set that to automatic, and RhinoCAM will automatically determine where that clearance plane is for you. And for the cut transfer method, we'll just set it to the clearance plane. Now for the cut parameters on the roughing, we're going to leave the tolerance to 10 thousandths, and we're going to have 25 thousandths of stock left on the part. So when we're done roughing this, we're going to leave 25 thousandths away from the part for our finishing operation. We'll use an offset cut pattern, and more importantly, we're going to define the step over distance for our tool. For roughing, we'll set that to 40%. And for our cut levels, this determines how deep you're going to cut. Now I mentioned that we have a split plane here, so we can go ahead and define that as our depth that we want to go down to. We'll check the bottom box, and then we'll go ahead and pick the split plane. So that determines how deep your cut's going to be. And we also have flat areas on the part, so we want to make sure in our roughing that we go ahead and clear those with the flat end mill. So we'll go ahead and check the clear flats box here. For our engage and retract, we'll just use the default parameters and generate the roughing operation. So turn the toolpath on. So you can see we've got a nice 3-axis toolpath created here, and you can also look at the toolpath and levels. Horizontal roughing is a roughing and levels operation, and you can look at each level as it works its way down. So let's go ahead and simulate this. So we'll select the operation and pick play. And you can watch the simulation with the tool path displayed, or you can turn that off to get a better view of the operation. So there's our roughing operation. It's left 25 thousandths of stock away from the surface. So let's go ahead and create our finishing operation. We'll go ahead and go to 3-axis. We'll do a parallel finishing. And again, you don't have to select anything here, but let's go ahead and confine it to the split plane. We'll go ahead and select our split plane. So there's our containment region. And for the tool for finishing, we'll use our ball mill, 3/16 ball mill. Feeds and speeds, we'll make sure they're loaded from the tool. Clearance plane is the same. But the cut parameters, we're going to use a 1,000th tolerance. And for stock will be 0. We'll be cutting it right down to the part surface. In your parts, you can leave stock and come back with another operation to make excessively finer finishing cuts if you wish to. We'll use a mixed cut direction. And for the angle of cuts here, we want to cut crosswise across the part. So we'll leave that set to 0 for our angle of cuts. And we'll go ahead and set our step over distance for finishing. Let's set this to 15% of a smaller step over for finishing. Z containment, we don't need any containment here because we're going to cut right down to our split plane. Entry exit, we can use the default parameters here and here as well. So let's going to generate that. So there's our nice parallel finishing operation. There's our 15% step over of the tool. And let's go ahead and run a simulation of this. So there's our parallel finishing operation being simulated. And if you don't want to wait for the entire simulation, you can always pause it and go to the end. And there's our parallel finishing operation. Now, another thing that I wanted to show you is once you have toolpaths created, you may want to get information about the toolpaths. You can just right-click on any toolpath or the entire setup and pick information. And you can get information about your setup for each operation. You can get the estimated machining time, the number of go-to motions. Here's your tool listed. And for our operations here, it's about 1 hour and 13 minutes of machining time if we run the operations back to back. And then also you can generate what's called a setup sheet. And this is a just a shop document, an HTML document that you can display and print out of your setup. So let's go ahead and right-click on the setup, pick Shop Documentation, and we'll go ahead and pick Save that, and it's going to generate a document and it's displayed on the screen here. Now this is an HTML document that has your stock dimensions up here. It has the picture of your part. It has your tool list, and it has each of your operations listed, and there's other templates you can use to provide even more detailed information about the setup, and your students can use this to print out and submit to you with their projects. Now, also, obviously you're going to want to post this out. So let's go ahead, and you can post any one of the operations, or again you can select the entire setup, and we'll right click and pick Post. And here is our posted Gcode file. We have our setup, our work 0 defined, our horizontal roughing, and here is all of our go-to motions for the Haas controller to machine both the roughing and the parallel finishing operation. And you can just output this file on a thumb drive and carry it to your machine and run the program from there, or if your computer is directly connected to your machine, you can just send the file to it directly. Now that's basically it for the first half. Now I wanted to go ahead, and I've got the second half loaded in another session here at Rhino. So here's the same part, and here's our first setup, and here's our second setup for the bottom. Let's go ahead and do a quick simulation of the first setup, and we'll just pick the setup and pick play, and it'll go through that real quick. There's our parallel finishing operation, and I also added a 2.5-axis profiling operation on this particular version of the part. And on setup 2, this is our bottom, so we'll just do a rotate up a little bit and go ahead and simulate side 2. So there's our roughing. Gone through kind of quick. We had a parallel finishing and then also a horizontal finishing. I'll show you that. There's our parallel finishing. There's our horizontal finishing to clean up these sides, and then also added a 2.5-axis profiling to clean that up on the sides. So that's basically it. Real easy to create toolpaths in RhinoCAM. We've done a lot of work on the interface that makes it real easy to use, especially for new students or young adults who have not experienced CAM for the first time. So Uday, if you want to go ahead and switch back to you as the presenter and show our next slide. Okay, Uday, thank you for that. You can go ahead and do the next slide. Okay, great. So now what I'd like to do is we're going to hand it off to Anita, who's going to review MecSoft's EDU products and resources. Uday, if you could, we've got that slide available. If you could just switch it over to Anita's screen, and she'll take it from there for that short demonstration.
Thank you, Don. Hello folks, this is Anita, and a lot of you probably already spoken to me on the phone. I'm glad to help you out with our details on our educational products. And you have seen how RhinoCAM works and how it's been a very productive teaching tool in the architectural department of Bill's School, Montana State University, and in Drew's Industrial Technology classes in the Wrangell Public Schools up in Alaska. For my part, I'd like to throw some light on different options for the educational products we offer. I'll step you through our website, MecSoft.com. This way you can access all this information later at your leisure. Now, what you can see on your screen is our homepage. Let's start under the Industries tab. Click on the Industries tab, go to the Education option, and it takes you to our education portal. As you can see, now this page gives you a variety of information, a lot of information here about what we do for our schools. Let's start with the solutions we offer. Now, there are basically two solutions we offer for your schools. They include the lab licenses, what we call a campus CAM license. Either of these solutions can run embedded in Rhino, SolidWorks, or in our homegrown Visual CAD design system. Now, within the lab licenses, note that these are all floating licenses. You can choose anywhere from 1 to 100 licenses per installation. Access is restricted to a lab or a classroom network. Now, this is just like Rhino, same as the Rhino network licensing. There are different configurations of our product, but for our schools, we'd like to offer all the features. So we offer the professional and the premium mill configurations. More popular among the two is the professional configuration of our mill product. Now we also have the turn, nest, art, as well as the 3D print modules, and they're all priced separately for this educational market. So this gives you the flexibility to choose what you require for your institute. So if you have only a lathe machine in your school, you could opt to purchase only the turn module. So or if you have a 3D printer, the 3D print module would be a perfect solution for your Rhino students. Now, the other option we offer is the Campus CAM solution. Now, this solution, as the name indicates, is a campus-wide site solution that serves unlimited number of CAM licenses. Now, this facilitates access anywhere within the campus network. So the students, the teachers, all can access this product from anywhere, located from anywhere, maybe their dorms, as long as they're connected to your campus network. This is a great solution for a lot of schools. The product, again, is available both in professional as well as premium configurations. The turn, nest, and 3D print modules can be added on if needed. Now, to be noted here, this is a yearly subscription license and needs to be renewed every year. We have a large number of schools like Carnegie Mellon, Texas A&M, the Ryerson University up in Toronto. We have Columbia, the picture you see right here, that's Columbia. And of course, we have Bill School, Montana State University, who enjoy the Campus CAM solution. Now, that actually brings me, you might be kind of curious what other schools use us. You can go through our customer list there. We have it segregated as the North American institutions. A whole slew of our schools use our solutions, CAM solutions, in and outside of the U.S. So we have them listed here if you're interested. Now, what I would like to add is we are a California-based company, and I'm really proud to say that all the University of California colleges are pretty much using our RhinoCAM solution. So I'm very proud of that one fact. Starting from Berkeley to UCLA to SD, all have RhinoCAM running in their schools. Now, apart from this, we have, you've heard Drew and Bill talking. We have a really nice page here. We have all the stories from different schools that have written case studies, and it's a really nice, fun read if you have the time to do this. And then we have our gallery here, which is another fun place to be. You can see all the projects that our students have created using RhinoCAM and our standalone CAM, starting from prototypes of car designs. There you go, that's one of the art schools that designed that. Glass vases, to a lot of furniture making, even that cool, where's that go? The skateboard that a RhinoCAM student created. So a lot of fun projects there for you to see. Now, the other thing that might be of great interest to you is the resources we offer. We do offer a large number of tutorials that would make the instructor as well as the students' teaching and learning experience really enjoyable. We have some video tutorials on our website, and then we have what we've put together, our CAM Jam video. This is about 80 detailed tutorials put together by none other than our presenter today, Don LaCourse. You've heard him, and I'm sure when you run these tutorials you will recognize his voice. So this CAM Jam set of videos, they're very detailed. You can have, we've put together 2.5, 3, 4, 5-axis tutorials, and this is really a great tool for our teachers as well as students to go through and learn our product. We're really trying to make it as easy as possible to have our students learn the machining process, and using Rhino and RhinoCAM, this is an absolute great resource that you can access. It is given to all our schools, and to use it as your teaching tool. Now, last but not the least, website. I'm sure you have this burning question here. What is this going to cost my school? Now, I will take you to our pricing page. We have lab licenses starting at $12.50, depending on where you are in the world, euros or dollars, and the Campus CAM solution is the $3,000 solution. Now, lab license do have an optional maintenance subscription plan, whereas the Campus CAM, already being a subscription, includes this yearly updates, what have you, for the CAM solutions we offer. Now, apart from this, I'm really happy to announce a 10% discount to all the attendees who are interested in our RhinoCAM or VisualCAM EDU solution for your schools within the next 30 days. Feel free to give me a call or give our office line a call, or write to us, sales@mecsoft.com, or personally to me, Anita@mecsoft.com. We will take care of any details you need or any help you need demoing the product to your school, your professors, your students, to help you make that decision. That's all I have done. Would you like to take over and maybe go to the Q&A?
Yes. Thanks, Anita. Uday, if you can move it back over to okay, there we go. And go ahead to the next slide. Okay, now it's time for our question and answer session. If you have any questions about anything you've seen today in today's webinar, just type them into your chat window and we'll be glad to answer them. Also, if you have questions for Bill and Drew regarding their presentations, they're still with us, so if you've got any questions for them, go ahead and type them in. I have one question initially, both for Bill and Drew. Given the age differences of your students, I'm just curious what CAM concepts you feel are more difficult for them to learn than others. Bill, we can start with you if you want.
Me, Bill?
Yeah, go ahead.
One of the things that we deal with is we're not teaching students how to do this as a career. We're teaching them how to make stuff. So one of the hardest things that I have to teach them is just the material itself and how to mill it. How fast can you cut wood? How fast can you cut metal? The hardest thing for me is just that. They understand the digital world. They're comfortable in that. And for me, it's just the stuff that most of us who make things already know. That's the problem that we have.
Drew, I'm curious. I want to switch over to you with the same question. I'm curious about how the younger adults in your school have embraced the CAM technology in fabrication?
Well, to give you an example, the young lady that made the grave marker this last year, she went through the tool paths and everything, and it was a pretty basic V-carve and you know, the 2D outline and everything. But tell you what, when it actually came to running the machine, she was just about flat terrified, because the piece of wood that she was cutting was about a $200 piece of wood, and was concerned that she had made a mistake, even though we had run the file about 4 times on cheap plywood. She was very concerned. But
yeah, I can understand that.
Yep, like Bill said, it's, you know, they can pick up the digital aspect of it, and they can see it run on the computer, and they believe the computer. But then, like he said, understanding how, you know, and I had to talk about densities of maybe a knot or whatever and stuff, understanding how that material will react is, like he said, an amazingly difficult thing for them to understand. But like Bill and I, you know, he and I have cut thousands of pieces of wood and plastic and different pieces, and we understand how that material will react to the machine.
Right. Great. Also, I'm curious, also if you have any questions, please type them in the chat window. But I'm wondering, Bill, let's go to you. How did you, or what process did you use to create the curriculum for your classes that include the RhinoCAM?
Well, we do have a structured second-year graphics program. Students learn how to use Rhino, and that's the start. And then we have them mill small objects, and mostly it's chunks of foam, about 6 by 6, and we've introduced it into the graphics program in second year. And then the students all know that the shop's available to them from that point on, and they some students don't use it till they get in my classes, and I teach not only these classes we talked about today, but dedicated furniture design and chair design classes, and then they come back to it. Some students really get interested and keep going with it. Great.
Hey, Uday and Joe, did we have any other questions from our attendees?
Not right now, but I have a comment to make. You know, one of the modules that we do have is the free mill product that runs completely inside of Rhino as well. And Don, you actually, when you showed the drop down, you kind of moved over that free mill.
Yeah.
Yeah, what I wanted to let our attendees know is, you know, that's a great way for your students to, you know, run CAM. Free of cost. It's a completely free product, so you can get that product. I actually download our product and run free mill. You can actually machine small parts. In fact, the Pittsco part that you had, Don, can be completely machined using free mill.
Yep.
And it includes all of the post processors, so you know your students can use it. They can build little parts with it.
And so actually, it's a good way for them to learn initially about the program and
exactly, yeah. So yeah, without even spending any money, you can actually take it and run the product. So I just want to bring that to our attendees' attention here.
Uday, I would add to your comment there. The free mill, I was struggling with the Bobcat cam one weekend, trying to help a paddle making class make a 3D paddle on our mill, and couldn't get it to work. I downloaded the free mill, plugged it in, and within 15 minutes I was able to cut the paddle, and that was the decision. Wow. That was the moment that made my decision to buy the actual the RhinoCAM, because the RhinoCAM offered the ability to pick and choose your tool paths a little more and decide how you wanted it to cut. Whereas the free mill
that's great.
Yeah. So that was the deciding thing. It gave me the opportunity to try your product and get a feel for how easy it was to use.
Yeah, I think there's a question here, Don, from one attendee saying, what is the limit of free mill? Let me address that.
Okay.
The free mill is actually, there's only one cut method associated with free mill. It's called parallel finishing. But you could do both roughing and finishing with that method because we allow different cut levels. You can associate different cut levels, and you can do roughing as well as finishing with that part. So any 3D part that you have for a 3-axis part, I mean, obviously you can't do 4 or 5 axis, but if you have a 3-axis part or even a 2.5-axis part, you can machine that with a little bit of creativity on your machine tool. So I hope that answers the question.
Any more questions, everyone? Just type them in.
Well, I'd actually like to make a comment here. We talked a little bit about this earlier before we went on the air. We've been using RhinoCAM for a long time, and I just can't say enough good things about it. Joe and Anita, Uday and Don have been absolutely impressively responsive to our needs, and we use the Campus Cam. It's performed without a flaw for us. The company, your company, and I swear you didn't pay me to say this, but you guys have a quality product, and the way you structure your education and the way you sell your products is absolutely the best.
Well, we appreciate that, Bill. We also appreciate you taking the time.
Well, and if there's anybody, and I'll offer this to anybody that wants to contact me personally, if you don't feel comfortable talking on this forum, please call me. Please email me at Montana State University. I'm in the directory. I'm the only Bill Clinton on campus, so I'm more than happy to help anybody out.
Okay, well, I appreciate that. Any other questions, Joe?
I just wanted to thank Bill for his support. We've known Bill for a long time, and he's always been there to help us out. And he's come out here for training, and we met him, and he's just an incredible guy. And he's a very talented person, so you can talk to him. And I hope, Bill, you don't regret your comment about having people call you, because we are recording this, and we're going to make this available to a lot of people. So you might get a whole bunch of calls.
I hope so. Thank you, guys.
Thanks, guys. Well, that concludes our webinar for today. I want to personally thank you, Bill, and Drew for taking time out of your busy schedules today to be with us. I also want to thank all of you, our attendees, for joining us. We're very glad you could attend. We hope you walk away with some helpful information about MecSoft's CAM products in education. If you have any questions about our presentation today, like I said, it's being recorded and it will be uploaded to our YouTube channel in a couple of days. If you have any questions about our presentation, or if you want additional information about any MecSoft product, please feel free to give us a call or chat with us online at www.mecsoft.com. Thank you, everyone, and have a great day.
You too.
Take care.
Bye-bye.